Our next speaker today is Grega Mulchinski from the Synergize, and he will explain how to use the satellite images in various types, various areas in businesses. So at this point, I'm asking the ATM support.
Yeah, I already informed them, so I think they are ready. So maybe I just do a short introduction and then we start. Yeah. So hi everyone. As mentioned, my name is Grega Mulchinski. I come from Synergize, and our company is dealing with satellite data, how to make this data available to as many people as possible. And obviously the data can be very useful in the insurance business because they provide an ongoing monitoring of our planet. And here by ongoing, I'm referring to, I don't know, a couple of days revisit time. And you can get the data even for the past if you haven't planned for it. Now, it will be my colleague, Marko Repše, who is a mathematician by profession, explain more about what we do with the data, all the complexity behind it, and how this can be made it easier for others. Marko is currently in the area with bad internet reception, so he pre-recorded the message up front, and I will ask the IT support to release the video, but once the video goes through, then I'll be available for questions and answer, and Marko might be able to join us as well, depending on the connectivity. So without further ado, I suggest that we listen to Marko, and I'm asking the IT support to start the video.
Hi everyone, thanks for joining us today. I'm Marko and I work on Sentinel Hub, and today I'm going to give you a short presentation on Earth observation methods and data. So our agenda today is actually going to be in two parts. First of all, we're going to have some slides where we'll be asking ourselves what is Earth observation in the first place. Then we're going to have an overview of satellites and data and options of how to access and process it. This will follow with some basic remote sensing concepts, and then we will have an interactive part with basic data analysis with plenty of examples. And finally conclude with how to do machine learning with EO data. So if we start off with an introduction, this will mostly be a condensed presentation of concepts and an overview of what can be done. Unfortunately, much will be left unsaid due to a lack of time, and we will try to not overload you with information. Mostly also it will be from the perspective of what is available on Sentinel Hub. So the idea here isn't really to tell you so much how to do things, but mostly help you help yourself, because there is a wealth of information online from papers to webinars, etc. In general, also these concepts presented do apply even if you do not use Sentinel Hub. But what is Sentinel Hub? It is essentially a satellite imagery service and API, and you can use the APIs to retrieve and custom process satellite data over any area of interest and time range. And this is done from the full archives in a matter of seconds, because no data is pre-processed. So what is Earth observation? Essentially, Earth observation is gathering information about planet Earth. And the context here is satellite-based remote sensing. So why use satellites? They allow you to see the entire Earth regularly, and this includes hard to access areas, either they be physically remote, politically remote, etc. Also, lots of data is needed for climate change monitoring, and satellites can provide that. You can also see hurricanes all at once, and no other method offers this, as you see in this example right here. To continue with an overview of satellites, we can roughly split them into two groups. You have optical satellites and radar satellites. Optical satellites will be familiar to most people, I think, because it is essentially like taking a picture from space. Now, since you are in space, you are affected by clouds and you are imaging through the atmosphere. So if you have a look at the top two images, the one on the left, it's slightly blue, it's slightly hazy. Well, that is the atmosphere. So then someone invented the so-called atmospheric correction algorithm, which essentially estimates what the ground would look like without the atmosphere. So that is the atmospherically corrected data, and you can actually access both. Radar is actually very different to optical imagery, because it behaves completely differently. It sends its own signal, it receives its signal back, and then looks at the difference. Essentially, radar is also unaffected by clouds, because it uses a completely different wavelength to optical imaging. And as such, it is much more difficult to master. It requires a much higher learning curve. Another benefit is that it is active, so it basically generates its own light, unlike optical, which require light from the sun, so it can image day and night. Next up, an overview of bands. So bands, which are sometimes called channels, are basically intervals of the electromagnetic spectrum which a detector can see. So you can roughly think of them as colors, and each satellite contains multiple such detectors. So in this image, you see the multiple detectors of multiple satellites overlaid over the atmospheric transmission curves. So the first satellite we're going to look at is Sentinel-2. This is actually the most used data on Sentinel Hub, and it's an optical satellite which offers 13 bands. The resolution is typically 10 or 20 meters resolution per pixel, but you also have some bands at 60 meters. ESA also provides scene classification, so essentially telling you what it thinks is on the ground, be it vegetated or built up. And in addition to this, Sentinel Hub offers cloud masks, which tells you which pixels are cloudy for each image. And this is super handy if you're doing data analysis and do not want clouds to interfere. Our next satellite is Sentinel-3. This one actually carries multiple instruments, and it's mostly used as an optical satellite. The Ulchi instrument has 21 bands, and the SLSTR instrument contains 11 bands, and these include thermal infrared. The resolution is about 300 meters per pixel for Ulchi and 500 to 1 kilometers for SLSTR. The main purpose of Sentinel-3 is to detect ocean and land temperature and color changes, but if you have a better idea, feel free to use it. Next up, Sentinel-1. This was, as the name implies, the first Sentinel launched, which was in 2014, and this is a radar satellite. The resolution is about 20 meters per pixel for GRD data, and this is provided at 10 meter pixel spacing, and we won't go into detail about what this means. So radar is also inherently noisy, which we call speckle, and as we mentioned previously, the high learning curve is an issue for many users. So that's why on Sentinel Hub, you can actually get analysis ready data by using select presets. Next is Sentinel 5P. This is an atmospheric monitoring satellite, and it can monitor air pollution. So for Sentinel 5P, there are available multiple derived products which measure various atmospheric gases like NO2, O3, CH4, and various cloud properties. And these are derived products because they aren't measured directly, but are computed from what the satellite actually measures using various algorithms. One nice thing about Sentinel 5P is it offers daily global coverage, and the resolution is up to about 5.5 times 3.5 kilometers per pixel. This may not seem like a lot, but it is actually considerably better than previous generation satellites. So for this purpose, the resolution is actually high. Next up are the Landsats. Now, the Landsats have a rich history starting in 1972 when the Landsat 1 was launched. Landsat data also became free and open in 2008, which means that after 2008, you have regularly intervaled data. While before that, you still have data, it's just not as regularly intervaled anymore. Landsats are also optical missions. They also offer thermal bands in the later, but this is not present in the earlier missions. So you can see in the next point, it started with 4 bands with Landsat 1 and continued to about 11 bands with Landsat 8. The resolution has also increased over time from about 80 meters per pixel to about 30 meters per pixel. And of all the satellites we have reviewed and will review, this is most like Sentinel-2. The next useful data you can get is the digital elevation model. So a digital elevation model either tells you the height above sea level or the height above an ellipsoid, and you can actually get both on Sentinel Hub, and it is global. ESA provides the Copernicus DEM. So the Copernicus DEM is either 90 or 30 meters per pixel. It is global, but you can get up to 10 meters per pixel in EEA areas with a license. Also provided is commercial satellite data, and unlike the previous examples, this data is not open because you need to pay for it. And you can order and use it on Sentinel Hub on demand. These are optical satellites, and they offer much higher resolutions, up to about 0.5 meters per pixel, and they generally offer 4 bands, so RGB with 1 near infrared band. The providers we have are Airbus, Maxar, and Planet. Another handy feature is bring your own data. So you can use your own raster data on Sentinel Hub, provided some conditions are met, like the image is in TIFF. And once you have done all that, it basically behaves as any other data. So on the right can be anything, like a scene classification map or a probability mask or whatever. So next up, we will have a quick overview of where you can access data and then how to process it. So the most basic are the online viewing tools, Sentinel Hub Playground, EO browser. There's also Request Builder, and we'll have a quick look at this in the interactive part. Then the Sentinel Hub API has docs here, which you can use. Finally, there are also libraries, and these are open source, Sentinel Hub Py and Sentinel Hub JS for Python and JavaScript, which interface to the Sentinel Hub API. For processing data, if you have large areas and/or time ranges where you do need a file output, you can use the batch functionality. The benefits are that it is low cost and it is asynchronous. But as of this presentation, only enterprise accounts can use it. The next useful feature is the Statistical API. And this calculates statistics only, but without returning satellite imagery, unlike batch. Again, this is programmable, and you can basically tell the system what to measure and return the values as percentiles, which you determine, or histograms, and you can have this on multiple dates with multiple outputs. Next, an overview of machine learning options. As we previously mentioned, Sentinel Hub Py. This is basically an open source Python API for Sentinel Hub services. And the upgrade of this is actually Elearn. So this is built upon Sentinel Hub Py, and it is mostly done to facilitate your machine learning tasks. The EO flow is actually additional code for deep learning approaches, and this connects Elearn with TensorFlow. And there's also a work in progress, unnamed library right now, which is similar to EOFlow, but this connects Elearn with the PyTorch framework. So next up are some remote sensing concepts. The simplest concept is the so-called band combination. It is essentially taking satellite band values and placing them into the RGB channels of an RGB image. So for example, if you want a true color image, you just take the RGB channels of your satellite and you place them into the RGB channels of your image. Easy. You can also get a false color image by choosing any other satellite channel in a different order and placing those in the RGB image. So for example, the image on the top right is a false color image. Next up is the concept of indices. Indices are essentially functions on bands. So you can have as many bands as inputs. An index will return a single value as the output. And the most well-known index is the normalized difference vegetation index with the formula as on the slide. So NDVI is the near infrared value minus the red value divided by the sum. And in general, there are many indices, and they're available on the index database, which we will show you a little later. Then the last concept is the concept of a custom script. This is essentially a Sentinel Hub concept, and these allow you to define mappings from your input data to your output data, whatever that is. So this also means you can have different dates, you can have data fusion, which means you can have different sensors all in the same script, and you can combine all this into any output combination you want. It's essentially a single pixel based approach. So you can't do convolution, but you can do pretty much anything else. And unfortunately, we don't have time to go into custom scripts, but you do have a 1-hour webinar just on this topic. So we will just mention these mostly as concepts and then show you examples. To start off with the interactive part of this presentation, let's have a look at Sentinel Hub Playground. So basically, this is the simplest view we have, the easiest way to view and get data, and it's very interactive. You can just move around, zoom in, zoom out, you name it. You can also choose different dates. So you just click here. Let's go back 2 months. And you get data from that date. If you want to switch, you can also switch to, for example, Sentinel-1. You click here. This is Sentinel-1, but let's go back to Sentinel-2. So over here you have different options for rendering. This is the standard true color. Here we have the standard false color, and here are visualized indices. So this is the vegetation index, but with a color mapping. This is also a moisture index, also with a color mapping. Finally, if you want to customize these visualizations, you can just click the custom button here. And the simplest offer here is to just use band combinations. So if you want true color, you just drag in the right bands. But if you want something else, you can do that as well. Finally, if you click here, you have the option to use custom scripts. Now, what custom scripts? Let's just keep things simple. Let's just go to the custom scripts repository. This is right here. This is something we provide, and it provides a list of various custom scripts which people use. So down here, you have the relevant reading section. There's lots of information about what scripts one can use, what scripts are being used, and what you can do with them, best practices, and so on. But in general, if you're interested in some scripts, you can just click here, for example. Let's just go to Sentinel 2. And here you have a list of scripts which are useful in one way or another. So if we just start off with some simple remote sensing indices and just pick one. So let's just click GNDVI. You have multiple options. You can just show the script. You can copy paste this into Playground. Click refresh, and this will show you this value. As you can see, this is actually returning an index. It's not visualized, so that's why it's grayscale. But in general, if you're interested in more indices, there's a collection of remote sensing indices from the index database. So you can just click here, and you have a lot of these, which you can use directly. And these are the ones which are present on the index database. So this is the index database. If you're interested in various applications, you can just click around. In general, if you're interested in a list of available indices, they're also right here with the formulas. Also offered are references. So if you click here, you get a list of references for this index. So you can really just use these to maybe get some ideas about what to do with your data. So this roughly covers Sentinel Hub Playground. Now, if we move on to EO Browser, this is right here. We will not be getting into details about all the features of EO Browser because there's also a 1-hour webinar just for this application itself. But in general, you can think of it as an advanced Sentinel Hub Playground. And we will be showing you an example of simple change detection. So it's actually really easy. There are some highlights. Oops. Let's go through change detection through time theme. And there's some highlights here. So if we just click here, we're looking at Egypt in 1984. And if we'll just quickly add this to compare, and then going to Egypt in 2019 and add this to compare, then you can slide this around. You can see that you can use EO Browser for some very easy change detection. So basically, this is 35 years of difference, and it's pretty obvious that things have changed. So for our next EO Browser example, we will actually be showing you an example of flooding. So this area, which we have already set up, is actually Lake Cerknica. It is a well-known intermittent lake in Slovenia, and we will use it to showcase flooding, as well as show you the difference between how these applications for Sentinel-2 as well as Sentinel-1. So over here we have basically Lake Cerknica, and we're actually going to switch to the shortwave infrared combination because it highlights water rather well. So over here we have the time-lapse tool, so we'll just click here. And let's just move in time forward a few months. So let's just go to the end of March from roughly the beginning of January. Let's just get all the images. And then here we have a time lapse already set up. So if we click play, you can see there is something going on, but there are a lot of clouds. So you can see that optical imagery does work well, but you do need clear skies, especially as this was in the winter where this part of the world is rather cloudy. So let's just stop this for a moment and switch to the Sentinel-1 time lapse. Now we already have this set up, so it's roughly the same time frame. So from the beginning of January to the end of March. However, this time we'll be using Sentinel-1 since it can see through clouds. So if we do the same, you can see that there are no issues with clouds, and that the lake nicely floods and then it nicely recedes over time. So Sentinel-1 is a really great application for flood monitoring because of that. Now you might be asking why this works. Essentially water, or still water, so water which isn't too rough, it acts as a mirror for radar waves. So since the satellite images from the side, it basically just bounces off. That's why the wet areas are nice and dark. Our next example will be to showcase wildfires. So over here we have a wildfire open in EO browser, and you can see that the true color image does give you an idea of which areas are burning. But of course this is not the only information you can get. So just by switching to false color, it becomes a bit more obvious that this area had something going on, even though it's maybe not completely clear from the true color image. Next up is the atmospheric penetration preset, which is quite amazing because it uses the shortwave infrared bands to see through the smoke. It also highlights the various hotspots as bright areas. So essentially, let's not forget where we're actually viewing here. So these are not necessarily fires actually burning. This might simply be residual heat from areas which used to burn, but then again, they might be active fires. So this might be a good candidate over here. Then also useful are the various indices. So if you just click on moisture index, it becomes pretty obvious which parts are fine and which parts were burned, as well as the normalized burn ratio index, which does something similar. If we have a quick look at NTVI, it's actually not as obvious as the other ones. Then finally, there's this wildfire preset here, which looks quite like the true color image. It just cheats a bit by taking the shortwave infrared bands to highlight these areas in the image. But again, as we previously mentioned, this isn't necessarily fire on the ground. These could just be residual heat, spots with heat. So this is pretty much wildfire monitoring using Sentinel-2. But it might be interesting if we actually switch to Sentinel-5P, because this is the air quality satellite. So let's just switch to the aerosol index and choose the same date. So this was in July, I think, 2020. Yeah, so you can see that something is up. And if we switch to a more obvious example, these are actually the California wildfires from late summer of 2020. So we have this already set up as a time lapse, and you can see that the aerosols, which Sentinel-5P can measure, really become massive. So you can see the wildfire starts, it burns, there's quite a bit of aerosols, and then it just explodes. And it covers the whole of the United States as well as Canada and other countries. So it's really massive. We would also like to briefly take the opportunity to showcase the ESA race website, which essentially is a website which shows the impact of COVID-19 as seen by various satellites. So Sentinel-5P, being an air pollution satellite, was definitely used to monitor air pollution during the pandemic. And it was used to see how much pollution levels dropped. So you could get more information here. In our next example, we would like to show you the Ulysses Water Quality Viewer, and this was actually submitted by the community through our custom scripts contest. So if we just have a quick look at the script, you can see this is a pretty serious custom script for obvious reasons, because there was quite a lot of science behind it. So the Ulysses Water Quality Viewer, in essence, will visualize these values, so chlorophyll and sediment, and put this into a simple way that it can be human viewable. It's also parameterizable, and there's lots of scientific and technical background, which is all explained here, as well as an example. But in essence, let's just have a quick look at it in EO browser, which we can do by clicking here. So let's have a look at Lake Balaton in EO browser. Give this a moment to load. And yeah, this is the Ulysses Water Quality Viewer on this date. We can switch dates. Let's see what happens. Yeah, you get a different water quality. The next example is the Tracking Radar Vegetation Index, which is actually another script from the community. And this one is interesting because it actually calculates a kind of radar vegetation index without using any optical data. So it's also a multi-tuple script, so in the sense that it combines different dates to get its data. And over here you have a general description, and over here an example. So basically it classifies according to color, and you can play around with this in Sentinel Hub Playground. So here we have it preloaded. It takes a little bit longer to load since it is multiple months of data. So we already have this open, but in essence, the different colors do tell you something. And since this is radar, there are no issues with clouds. So this is another tool you can use to get information from the ground. Our next example in EO browser will showcase commercial data. So this area in Africa, Dakar, has been selected for the Urban Growth in Africa contest. And lots of data has been prepared in advance for you, and this includes all the commercial data providers. So if we start off with a look at Sentinel-2 data, and for example, just zoom in here, you can get a feel of the resolution of Sentinel-2. But actually, let's add this to compare. But if we're interested in the commercial data, so let's say Airbus Pleiades, and I think we need to go back in time. Yeah. So we can have a look at the resolution of commercial data. So let's also add this to compare. So in addition to commercial data, this part also has the Sentinel-1 GRD process to analysis ready level. So if you're interested, you can have a look at that as well. So let's just pick one randomly, and then add this to compare as well. So this will showcase a few different satellites in the same area. So this is Sentinel-2. This is commercial data. So let's just zoom in more and maybe even reorder this a bit. Yeah. So you can see that Sentinel-2 was processed to about 20 meter resolution. This is about 10 meter resolution for Sentinel-1. And finally, if we have a look at the commercial data, which is at 0.5 meters resolution, you can see this is a whole different world of detail, which might be useful for you in your applications. But essentially, this is part of the Urban Growth in African contest. So there is actually a website here, and we would actually like to use this opportunity to invite you to this, because you can apply. So this has a custom script contest. Basically, the idea is for you to make sense of all this data, or try to make sense of all this data, and the person with the best custom script actually wins some nice prizes. So this is all on this website. You have time until July the 25th, and you can easily use this this data to play around. The last example we would like to quickly show you is an example of data fusion. So basically where you combine Sentinel-1 and Sentinel-2. And the idea here is to use Sentinel-1 to infill areas where Sentinel-2 is covered by cloud. So it will use a form of radar vegetation index to approximate the NDVI index values using Sentinel-2. So over here you have it on the custom script repository as usual. You have some standard descriptions and examples. So basically this is the area, how it looks like using Sentinel-2. And this is the NDVI value. Of course, these areas with clouds are suspect, so not values you want to use. So you use the cloud masks to remove these areas, and then you can use data fusion functionality of Sentinel Hub to infill this with the radar vegetation index, which approximates NDVI. So over here we have the same thing open in your browser. We won't go over the custom script, but basically this is a slightly more advanced option for you to use the functionalities of remote sensing data to make sense of what is going on the ground. So that concludes the basic data analysis examples. Now we'd like to point you to the education pages we have with much more information about satellite imagery and what you can do with it. So this is our education page. Over here you have multiple tutorials, how to make time lapses, some index tool, and various use cases. So monitoring pollution, having a look at the Mount Etna eruption, wildfires, and various user guides, including webinars. There's also more resources here. So this is the education page. The next one we want to show you is the industries and showcases. So these are examples basically more targeted to the various industries, so more for agriculture, land change detection, and so on. Also disaster management and the insurance industry, which you might be interested in. So these are these websites. So next up, we would like to show you the Sentinel Hub Request Builder. This is basically an online application which allows you to do Sentinel Hub API requests. It, in general, has everything you need in one place. So it's great for, let's say, advanced prototyping or things like that where you don't want to use EO browser, for example. But in general, it's really easy to use. You just plug in all these values here, which you need. You can change them without a problem. So let's just use band 8 instead of band 2. And then you can send this and get an image. So there you go. And this is actually true for all the Sentinel Hub APIs. So you can use it to make batch requests, to order third-party data. Then there's the catalog service, which gives you information about what satellite imagery is available when, and the Statistical API for calculating statistics, which you define. So if we move on to the last part of our presentation today, this is basically how to use machine learning with EO data. And the first thing we would like to briefly show you is the Sentinel Hub Python package. So basically this is an open source package, which is in Python obviously, and it allows you to make API requests to Sentinel Hub using it. So there is much documentation here in the read the docs. It will give some information about installation, configuration, basically everything you need to know to set up. And there's also a ton of examples which will help you get started. So if you're just interested in, for example, a true color on a specific date, it will tell you how to set up. So basically your eval script, your various parameters, and then you can just run this and you get your image. In addition to this, there are other useful tools available. So for example, the large area utility, this will allow you to split up your requests into bounding boxes which are manageable, because you can't make an infinitely large area request. And this is useful if, for example, you're not using batch. If you are using batch, you can also use the batch processing API, which is also part of Sentinel Hub Pi. It's just really useful to get data. But in general, if you want to run proper machine learning, so to say, then we get to the Elearn package. So this is the Elearn package. This is built upon Sentinel Hub Pi. Its main purpose is for preparing data for machine learning. And the idea is to help you bridge Earth observation data with machine learning. So basically, Elearn uses NumPy arrays to store and handle remote sensing data, which can then be fed to machine learning software. And basically, this is the Elearn website, which you can use to learn how to do this. So there are extensive docs. You can see there are also the blogs and papers section. So there are a lot of resources you can use to help you cover various examples and see how things are done. Or of course, if you want to do things differently, that's also fine, but this is a good starting point. Then if we just go for a quick overview of Elearn, basically it's these are the 4 concepts we will just briefly cover. So what is an EO patch? It's basically a data object for multi-temporal remote sensing data for a single area. If you think of it as data you're interested in, then it's an EO patch. Then if we continue to EO task, basically an EO task is it's something which functions on EO patches. So basically it takes in an EO patch and it returns an EO patch. So you have different options basically. You can definitely write your own EO patch. Sorry, you can definitely write your own EO task to modify EO patches in any way you want. Of course, you can always use pre-built EO tasks. So here are a bunch of EO tasks which are part of Elearn, and these are things which are already implemented and things you can use out of the box, so to say. As we mentioned, if you want to write your own, you can definitely do that. Elearn is open source. If you want to make something useful and want to push it, you're also welcome to do that. So that very briefly covers the EO task. So basically, EO workflow, it's basically a graph of EO task objects which you define. This is essentially things you want to do on your EO patches. And then finally, EO executor does the actual processing. So you have that here. If we continue to just mention EOflow is you could say it's another package built upon Elearn, and the idea is to help you make data ready for TensorFlow. So basically, to get data into TensorFlow so you can use it for deep learning. Now, if we go to a quick example in Elearn, so a simple one, it's basically for measuring the water levels of various dams or water bodies, you could say. But this is an example of this dam in South Africa. I won't even pretend to be able to know how to pronounce. So it's essentially a whole workflow for how to do this. You, in essence, basically import the polygons of the areas. Then you have methods to create EO tasks, and this is all available here. Of course, this is just one example, and if you want to look at this in more detail, for example, this is the website. This is the Blue Dot Water Observatory. If you click on the dashboard, you actually have the output of the previous example all on this website. And this is actually for water bodies worldwide. So for this example, it's in Turkey. The water level seems to be pretty constant. But if let's just go to some random water body in Africa, then apparently things are slightly different. And you can click around and see what happens. So this essentially uses the code we just looked, and these are the outputs of this on this website. Then the next thing we would briefly like to show is the Elearn Workshop. So this is pretty much a walkthrough of how to use Elearn in your applications. To be blunt, this is somewhat dated, but this will be updated in the next months for new challenges. So you can definitely use this. Just keep in mind to keep in mind that this might not be as up to date as one might want. But essentially, if you click here, you can launch the Elearn tutorial. This will take a bit of time to load, but essentially all you need is your browser, and you can play around with it in here. So let's see, notebooks. Yeah, so Elearn Basics. And here you have a nice tutorial about how to use Elearn to get your data set up in such a way that you can use machine learning. Here's also an example for the land use cover predictions for Slovenia. This basically has everything you need for you to be able to do this, and there are definitely blog posts about this, but this is essentially the code you can use to get to the same results. In essence, let's say for insurance purposes, we expect you to want to use these libraries. So basically Sentinel Hub Python and Elearn, as they will allow you to easily assess lots of data at once, build your probability models and whatnot, and then hopefully get some useful information out of this. So hopefully it wasn't too much information, hopefully it wasn't too little. So that concludes things. Thank you, and goodbye and good luck.
Okay, thank you, Marko, for this presentation. Meanwhile, there was a question about the links, which are already posted on the optimization on the conference webpage. So if you go to the timetable and then you click on the second presentation, inside there is a series of, I don't know, 15 links to various sites. So is there any question from the public regarding the presentation?
May I ask the question?
Of course you may. Hi, Marko.
Hello. Would you be able to measure the traffic with these images? How do you think?
So depends. Yes and no. So what we did actually is that so it's not possible to detect normal cars with this resolution simply because resolution of the Sentinel-2, which is 10 meters, is not good enough to detect an individual car. It is possible though with some trickery identify a truck because truck is just large enough and you can actually, yeah, I mean, it's an interesting thing to do. And what we did is that we measured a number of trucks in a given day. What is important to say is that, I mean, people usually have a misconception about the satellite imagery that it's just available all the time. In reality, it comes, I don't know, every day or every 5 days, right? Once per 5 days or once per day, and so on. So anyway, what we did is that we identified all the trucks on the roads in Europe, as an example, over a specific day. And then we compare this over a period of a month. And then we compare this like with the period 1 year ago. And in the COVID situation, especially last year, when there was quite a lot of blockages on the road, we were able to clearly show that the truck traffic has decreased for about 30%. I mean, different in different regions of Europe, but it was clearly shown. So yes, to some extent you can do that, but if you want to just measure traffic, then using mobile phones is probably better because every car has one and you have real-time information rather than just the sporadic one.
Okay, thanks.
Are there any questions? You can either write into Q&A or in chat or raise your hand. So I have a question. So can you, for example, show a concrete example how to say estimate the differences after the fire, before and after the fire?
Sure. Yeah, let me do this. So I hope you can see my screen.
Yeah.
Yeah, so I'm demonstrating in the EO browser, and I mean, it was not stated within the application, but EO browser is a web application which you can just go and just make use of it, right? You don't even need to register. If you register, you can get some additional functions, but I mean, yeah, most of it is free of charge and you can just make use of it. So anyway, here we are looking at the area, a typical area over, I think this is in Africa. And this is before the fire. Now, if we, and so that's an image of on 15th of May. And then if we go, for example, 1 month later, this is the same area after the fire. And I mean, you can already visually see, you see that there are some differences, as an example here. And you could then compare this visually. But what is nice is that you can make actually the mathematical calculation of the differences using so-called normalized burn ratio, which is defined here. I mean, it's a script. Let me just scroll down a bit. So this script, even though it might look confusing, but when you start looking to it, it's pretty simple. You compare, you take two different dates where you have the imagery. And then, so then basically what you do is that you take, wait a minute, you take these bands, 2, 3, 4, these are red, green, and blue, and then some red edge and shortwave infrared. And then you basically do a comparison of these prior to the event and before the event. And then you just use some thresholding, right? If it is less than 0.05, then you just let through the like the true color imagery. If it's more, it's yellow, which is kind of a medium damage, and red is a high damage, right? And you can, so what you see here, this is calculated on the fly. And now what you can do, and I mean what our users do, is that then they export this data, just an outline, right? Not the imagery, but an outline of these polygons in their GIS tools. And then they overlay it with the application, with the information about, let's say, properties. And then you have a very clear, I mean, again, important, this is not for the detailed assessment, right? You don't see, obviously, I don't know how much of a fire is, sorry, how much of a house has been damaged, but you can very quickly see which houses were actually impacted, which properties were impacted, whether they were in the severe damage area or in a mediocre damage area. You can do a similar trick for vegetation as well. I mean, let's say that you are interested in hail damage, so there is a hail and you have a large field of crop, and after the hail, the field of crop will be destroyed. And you can then take the imagery from the past, right before the event, because as mentioned, this data is coming in every few days. So there will be data there. And you can then compare these two data sets, and then you simply, you come up with an estimate. And what is the nice thing to do is that you can actually, with the vegetation, I mean, is that you can actually monitor then after the event as well, because as an example of the hail, some part of the vegetation will recover through time, and you can see this and then basically assess the damage, not just at the time of the event, but as a actual full scope yield and so on.
Okay, thank you very much. I mean, this was really impressive. I didn't have the foggiest idea what is possible to see with these satellites today.
I mean, that is, I think, one of the main motivation why we wanted actually to present here is that we give the visibility to people of how much data is available. And by the way, not all, most of the data that we've been showing are free data, right? So there are like Sentinel, Landsat, all of these are free data, which are available and can simply be used. Yes, you can go to the commercial data, as Marko showed, like Pleiades and Maxar and alike. But in reality, majority of these things is available on an ongoing basis, free of charge, and you really just need to use it. This adds a bit of a complexity, but again, we have shown that can be done easier, but for sure it's there and should be used. It should be used because it's really lots of value in it.
Yeah. So are there any other questions, comments, remarks from the audience? So as I already said, the links are within the timetable. So if you would like to look at that, please go and visit the optimization webpage, so where these links are provided. So thank you, Greg, and thank you, Marko, once again for this really interesting presentation. And now it's time for a coffee break, so we reconvene in 11:10.